Okay, so today we are going to be working on our new learning target for our new unit, Unit 5. Our target today is I can verify congruency through a sequence of translations, rotations, and reflections. And we're going to focus mainly today on the translation portion of that. So we first have to decide what a transformation is. And a transformation is an operation similar to like addition or subtraction. It's something that's being done to an original geometric figure, which we call our pre-image, onto a new figure, which is called our image. And if you recall back to elementary school, you definitely have worked with translation, rotations, and reflections before. However, translations previously have been referred to as slides, because we are going to be sliding figures across the coordinate grid. So in order to be able to slide them across the coordinate grid, we need to understand what the directions mean in relation to what we're doing to the x and y coordinates. So if you have a movement of going up or right, that will happen when you have addition as your operation. And if you have a figure that is moving down or left, you'll know that because the values are being subtracted. So for 8th grade, we are going to be using translation notation, which you can see in this highlighted box right here. And so what that tells you, it says there's an original coordinate, and we are going to translate it by the movements of what it says right here. So if I have x plus 6, that means every x coordinate on our figure SRQP is going to be moved 6 units to the right, because x movement is right or left. And then we have y minus 2, and if we're subtracting 2 on the y's, that means we are going to be moving down 2 for every single point in this figure. So we would say that this figure is being translated six units right and 2 units down. So if we look at our pre-image SRQP, the ordered pair for P is at -2, 3. And if I were to translate that 6 units right and 2 units down, 6 units right would be 1, 1, 1, 2, 3, 4, 5, 6, and then 2 units down, 1, 2. So my image of P is going to land at 4, 1. And we can verify that we got this correct, because if we take the x value, -2, and we add 6, just as our translation notation said, -2 plus 6 is 4. If we take our y value, 3, and we subtract 2 from that, 3 minus 2 is 1. And we can verify that we moved our image of P to the correct location. Now I want you to pay attention to how I wrote the image of P. You're going to add a little tick mark next to the letter that you're writing. That will, that will represent that that is our image and not our pre-image. So I'm going to do this for all of my other points. So for Q, that is originally at -2, 1. So I'm going to move that 6 units to the right and 2 units down. So 1, 2, 3, 4, 5, 6, 1, 2. So my image of Q maps to 4, -1. If I look at R, 1, 2, 3, -3, 1. And if I move 6 to the right, 1, 2, 3, 4, 5, 6, 2 down, 1, 2. We have our image of R, which is at 3, -1. And then our last point, our pre-image S, we move it 6 units to the right, 1, 2, 3, 4, 5, 6, and 2 units down, 1, 2. We get our new point, S, the image of S, which is at 4, 3. Okay, so let's look at example 1. It says translate triangle JKL left 3 units and up 4 units. So the first thing we want to do is write that verbal description into our translation notation. So the first thing that I notice is it says left 3 units. And left is going to be our X motion. And since left is a negative motion or subtraction, we would write X minus 3 as the first part of our translation notation. Then our second part of our verbal description says up 4 units. Up is a Y motion because the Y axis is vertical and goes up and down. And up is a positive motion, so we would say Y plus 4. So we first want to get the points for our pre-image. So J is at point 1, 3. K is at point 3, -2. And L is at point 1, -2. So you can translate this figure one of 2 ways. You can do the subtraction and addition to the X and Y coordinate, or you can actually move the figure on the graph by counting the boxes to the left and up. So if I am moving point J, first I'll show you by counting the boxes on the graph, like we did in our prior example, and then I will show you using the translation notation, which we also looked at in our prior example. So point J is on 1, 3. If I am moving left 3 units, so 1, 2, 3, and then I am moving up 4 units, 1, 2, 3, 4. My new point goes off the graph a little bit. My image of J is going to be at -2, 1, 2, 3, 4, 5, 6, 7, -2, +7. For K, at 3, -2, if I take 3 and I subtract 3 from it, and I take -2 and I add 4 to it, 3 minus 3 is 0, and -2 plus 4 is 2. So the image of K should be at 0, 2. So if I go to my graph, I would plot 0, 2, and I would label it the image of K. For L, if I move 3 units to the left, 1, 2, 3, and 4 units up, 1, 2, 3, 4, I would have my new point, my image of L, at -2, 2. And then you can connect your points to create your new image. Okay, so for example 2, it says describe the translation that maps triangle QRS to the image of triangle QRS. So to do this, we first need to identify which triangle is the pre-image and which triangle is the image. And all it is taking a quick peek as to how the points are labeled. So our upper left triangle is labeled R for that top point, and our lower triangle is labeled R with the little tick mark next to it. Therefore, our pre-image is in that upper left-hand corner, and our image is in the lower right-hand corner. So to figure out the translation notation, we need to verify what movement does it take to move triangle QRS onto the image of triangle QRS. So to do that, let's count our boxes. So first, we would see how is our triangle changing from left to right. We can see that it is going right. So I know I'm going to be adding to X. So if I count 1, 2, 3, 4, 5, I know that I moved over 5. So I would have X plus 5. Then, to get to the actual image of R, I know I have to go down. So I'm going to be subtracting from Y. And let's count. 1, 2, 3, 4. So I am subtracting 4. Now, good practice is that you verify that each of the other points also do the same. So we would count from S, 1, 2, 3, 4, 5, 1, 2, 3, 4. That checks out. And then if we go for Q, 1, 2, 3, 4, 5, 1, 2, 3, 4. That also checks out. So we know that we have the proper translation notation. And again, we can verify if we put our ordered pairs here. So 1, 2, 3, 4, 5. We would have -5, 2. And if I am adding 5 to -5 and subtracting 4 from 2, that gives me 0, -2, which is exactly where our image of Q is. R is the pre-image R is at -2, 5. So if we subtract, or if we add 5 to -2, that gives us 3. And if we subtract 4 from 5, that gives us 1. And then last but not least, we have S, which is at -2, 1. If we add 5 to -2, we get 3. And if we subtract 4 from 1, we get -3. And again, we can verify that those points match up to the ones that are graphed. So, the verbal description. Basically, take your translation notation and put it into words. So, triangle QRS is translated five units right and 4 units down. And that is all you have to write when you're verbally describing the translation that occurs between the pre-image and the image. Okay, At this point, I want you to stop. I want you to try example 3 on your own. And when you restart the video, you will see the answer magically appear. And we're back. So, how did you do? You should have gotten x plus 3 because it said we were moving 3 units right, comma y plus 3 because we were moving 3 units up. And if you did the math correctly, you would have your image of quadrilateral QRST falling at these points. So double check those. If you did not get those correct, go back, try to find your error, and make a note for yourself. If you have any questions, feel free to ask. Your homework is the following page. Make sure that you are being consistent and you are taking your time. All right, good luck.